I think one of the problems with Second Life was scalability, and we're still now talking about scalability like 10 years after the problems arise. So that's why we started looking at Second Life and to see how we can solve scalability in Second Life, even if Second Life is not solved something like a very hot topic. So let's go and see what's how we see the scalability problem. Okay, if you have one server, that is the most common setting for multi-user virtual worlds, evidently at some point you have a limit. So the limit can be n. N is something like around from like 50 to 10,000. Large. So the solution that is the one Second Life, the one that everyone knows, the zone, is the solution to scale. Actually, it is not a real solution. It still has a limit per region that is pretty similar to the one server limit. And also there is another problem, is that most regions are empty, because people tend to gather together to play or to interact. This is very normal. So that means this comes with a real cost. There is a sort of kind of scalability, because if you have many regions and you can have many peoples in many regions, so it seems it is scale, but it's not scale because people cannot gather together. You have a limit in Second Life, 50 person that can be together, and also there is a huge cost because mostly empty. You have the shard solution. Actually, it's not any solution. You have like servers, like those ones, and they look pretty similar. And you say the people they are not playing together. They are not together. They are just like doing the same thing but separately. So it's not exactly scalable. And what is strange is that 10 years after, we are still facing the same problem. I mean, the people just say, oh, we want to be more, and we still have the same problem. The problem is in the algorithmic side, because you have N2 interaction to N² interaction to compute. By interaction, I mean something can be very simple. It can be the collision. You have all the people here in the room. Are they colliding? You need to know are they visible, or how is the level of visibility. So that means that for each avatar, you have to scan all other avatars and to see what's going on. Should I show that on the screen or whatever? So you have N² interaction to compute. So that's why you still have the limit. Even you have more law, whatever, it's doubling every so. But still you have this problem. So that's why it's not yet solved. So having that in mind, we change the stuff. So, and this is Kiwano, the work of Raluca. So here we change it because Kiwano is something that is not exactly intended to solve the scalability of the world, but it was like this. You just send every avatar send its position. Say, I'm here, here, I'm here. And Kiwano computes in real time the neighborhood. Say, oh, you have moved, so now these are your neighbors. You have more neighbors. Or even if you don't move, if someone approach or get away, you all the time, it maintains the neighborhood. It maintains the neighborhood, and roughly it's around 70 person in the neighborhood. So your computations, the number of computation, you just have to see what's going on with all those people in the neighborhood. You don't know about more than 70 person. This is a kind of limitation, but it is quite acceptable for many users. I mean, if you want to interact, you are not going to interact individually with more than 70%. It's even too much. this is, we have this side, this side. Actually, you can change for it, we need more. But the point is that you can fix, you can have a limit of number of neighbors. So then the number of interactions, you have n interactions in computer. So that means that it can scale. You can add more and more and more and more avatars. Actually, you have a fixed number of computations per avatar. So this is the exact definition of scalability. It means that the cost of adding one, I mean, it's doable. So how now everything relies on Kiwano. So let me tell a little bit more about Kiwano very quickly because it's not the main topic. So the neighborhood is computed using a Delaunay triangulation for the one that knows that. It's Kiwano on the cloud and it's distributed on many machines. So that means that if you have more users, you just add more machines. It's kind of cost efficient because you have like around, we estimate around, depending actually the pattern of mobility of the avatars, but we estimate that we can accommodate around 1,000 users per one core. So it makes something like that. And it scales because the cost Kiwano is have a constant user, the cost per user that is constant. That is the number of avatars per core. That not depend on the total number of avatars. So it's. And also, what I didn't mention, because I was talking about the algorithm, Kiwano, as you have already the connection with the Kiwano, you can use it to send data to avatars. And we are going to use that for scaling Second Life. Kiwano has an open API, so that's why it's easy to connect and to code with Kiwano. So the OneSim architecture. The idea is the following. You have here Kiwano. You just have on each player's PC, you have the viewer, a classical viewer, I mean the OpenSim or the Second Life viewer, the normal one, and you get it downloading stuff. And then the OneSim node that we will say that in the next slide, and all this connected through Kiwano. So you can add more and more like this. And so on the name, here comes the name of OneSim. Just because with this setting, even though each one are connecting to a different server, these are kind of synchronized, so the people have the feeling of being all connected to the same thing. So that means that they will see around them no more than 70 people or so, and by walking, they will end up seeing everyone if they walk all around the space. And this without limit. So the OneSim node actually is mostly it's just an OpenSim server. So I know people will say we have to install the server inside our PC. It's a little bit complicated. This is more like to show how it could be done. Maybe Second Life is 10 years old or more system, but if we build a new system, we will have the same. You will need a simulator, you will need, and it will work roughly the same. So how it works? You have the viewer connect to the sim. So that's why you can use a normal viewer, because no unmodified one. You just connect to the normal OpenSim server. But in the middle, you have a proxy. So you connect to the proxy forwards everything, and so that means that the proxy can inspect the packets. And it will take the packets that are related to the state of the avatar, its position, but anything that has related to the state of the avatar, and it will send that to Kiwano. So all the others will see, all the others in the neighborhood will see the changes, the state changes of this avatar. So what is this? Let's see a typical movement. So here, the viewer just saying he wants to move 2 meters in a direction. So here it says that to the OpenSim. The OpenSim makes the computation, and I say no, 2 meters is not going to work because you are colliding with wall or with another avatar. So the answer will give the actual state of the avatar, the one that will be shown in the viewer. This state is here, is taken here, and is sent to Kiwano. So the others will see so here, imagine another avatar moves, so this will be sent here, and will be put here as a non-playing character. So this will be visible by this avatar. So that's why you'll see all your neighbors' movements, but the simulation is just done locally. So there are some drawbacks. For example, a typical one is you can cheat. Because since everyone is running his own simulation, maybe one will say, I have superpowers, I don't mind about what the simulator is telling me, I am sending here fake information. So you can cheat, actually. So, but, I mean, so maybe you need some control for some kind of, but it's like in the real world. I mean, when you are playing soccer, you need like someone to check if the people are not cheating. So you need a server or something that is not, you cannot distribute the not cheating mechanism. But here you will have something that actually works for social interaction, it will work for Second Life. So that's it. So this is probably running short of time. We'll just go on the last slide. So here you have so the links. You have the Kiwano API is just available there. You go on kiwano.ly. Don't ask me why just because the other was not available. So when you go on kiwano.ly, you have a version, a usable version of Kiwano API. Kiwano is running on some servers, so you can just connect and make your own experiments. Actually, someone makes some experiments here with Minecraft. Minecraft is scaling in Minecraft roughly the same architecture that we have I presented here for OneSim is the one that is used here for Minecraft. And this is running. There is the actual code. You can load the Minecraft node, that is some Java running stuff, and it will work as described. So actually, this was the inspiration for OneSim, because this was running, say, oh, but we can do the same in Second Life. And this one, it's about hybriders. It's a project with mixed reality, and this is the blog, so you can have more information here. Actually, I think I can even, I don't know if I can do that, like this. And even, while you prepare your questions, I can send here.
So, I think we are running out of time now. So, is there any questions for Jaoquin on the OneSim system that he has presented? Secret.
Can you please tell me why you treat all the avatars as NPC?
Why avatars as NPC?
Yes.
Yeah, because actually you don't have a real viewer connecting to the sim. You have only one per each sim, per each server. You only have one viewer. So maybe you want to see the architecture here. So you have so you have only one. You see the sim. You have only one viewer. This is a real player. It's because it's connected. You have the viewer. I mean so there's only one connected. So if you will be alone. So the others are shown as non-playing characters, but they are exactly like real. But you are using the non-playing character interface to generate the other users, since there is only one user connected.
Okay.
Any, Philip? I think that every of those servers is basically holding a local copy of the state secret.
So my question is, do you adding any overhead, like in delay or something, with your intermediate layer with your servers and Kiwano? Did you analyze that?
Actually, we haven't nothing running, and there should be some delay. So this is, for example, for a second line that is interacting. When you are sending on the network. I don't think the delay is more than the normal delay. I mean, since you have your server locally, you are running with your server, so this is shorter than connecting to a distant server. Now you send your data to a server, and then it came back to the other. The delay should be pretty similar as the two are connected to a server. Maybe there is a little bit, can be a difference because of Kiwano is running on many machines, so maybe it can be one more hop inside the data center where Kiwano is located, but it's a short hop inside the data center, so it should be not more than, so it should be similar of what is now.
So one question I have is, how do you handle state inconsistencies between the different OpenSim servers which are running on the different OneSim? I mean, what happens if two users are trying to modify the world in a conflicting manner? How does Kiwano handle that?
Actually, yes, it could be. I mean, if you imagine in our solution, we can assume that besides the avatar, everything else is static. If it's not the case, this could happen. If not, I mean, if some objects are not static, you should give them the responsibility to just OneSim. Like, for example, the avatar. For example, if you push another avatar, and but the other guy is just moved, I mean, there is no inconsistency because there is only one sim that computes the state of the avatar. You should do the same for objects. For example, if you have a chair and you move the chair should be assigned to a sim.
Okay. I think we've run out of time now, so thank you very much, Jaoquin. And then we will have to move on to...
someone that has connected here. So we are two here in front of the hybriders. So this is a demo of hybriders, just online here.
I think, yeah, if people are interested, you can speak to Jaoquin after the, or during the lunch break. Peter, if you want to come up just to present the work that you have done.